Good afternoon. Thank you for being here. My name is Ali Taslimi. I am a member of the Cambridge Industries Group, CIG, in Santa Clara, Silicon Valley. Today I want to discuss, I have an agenda, obviously a short agenda, and then at the end I will have some discussion about our company, CIG, in the US. So next, generation access networks is the topic of the conversation today. So the area that I'm going to focus on today is open source evolution, operators and suppliers' motivations, and also challenges, and SDN NFV challenges and motivations, and then introducing a next generation OLT, which we call it Open OLT, made by CIG, and then I'll give you some information about the company. So let's start with open source evolution. You know, everybody, when you talk about open source, the concept of open source for the past several years has been around, but everybody, when you talk about open source, the focus is software. However, today, the open source concept has actually advanced, moved on from just being software. It includes hardware, includes mechanical, includes FPGA. At least there's one service provider in the US that we're engaged with that they are actively promoting what they call open source catalog. By that means that in this catalog, they include hardware modules, software modules, mechanical modules. And the way is that they want to really promote their network operations group to go to this software, to this open source catalog, pick and choose different modules, hardware, software, in order to be able to actually put together a network or design a network or build a network which is performance optimized, which is cost optimized both on OPEX and CAPEX. So that's really what as a trend is happening, basically building that catalog. And of course, OCP is a member of or a concept within this catalog to build products which is SDN compatible, NFV compatible, OCP compatible. So what are the motivations and challenges that operators and suppliers, we're a supplier, that we are actually seeing in the market here? So obviously, the operators' motivation is, the number one is always cost. I mean, CAPEX is one-time cost. They're very cognizant of it, but it's one time. OPEX is a cost which is happening on an hourly basis, on a minute basis. So that's very important for them, how they can actually bring their OPEX costs down. Programmability, what does programmability mean? It means that, you know what, when there's a new market opportunity to offer new services, you want to be able to actually create those services and offer to your audience, to your market, much faster, much quicker. Today, the networks are constrained. If you want to really actually offer new services and features, it takes months, if not years, to actually implement those. Flexibility. They want to be able to actually mix and match different products from different vendors, because that will give them the opportunity to actually reduce the cost of CAPEX, create competitiveness among their vendors and ventures that they're working with. Now, what are their challenges? The concept that we just talked about, the open source catalog, the ecosystem is not defined yet. I mean, it's defined, but it's not really complete yet. In other words, you don't have an open source catalog that has all the elements in it, and they all have been working through the interoperability. So that ecosystem is not complete yet, but over time, over next few years, there is a very good opportunity for that ecosystem to be complete, and in fact, OCP is part of that ecosystem as well. What is the supplier motivation? What is my motivation as a supplier? Obviously, I want to be able to build products that I can access to a larger customer base, not only being specific in one area. So that's one area that I really want to focus on. So that will be an opportunity for us. But at the same time, we want to build partnerships and collaboration, close collaboration with service providers, because together then we can actually bring more innovation, new offerings, new solutions together. But the challenge, of course, for us is then market becomes commoditized, right? So there will be a lot of pressure on the margins So the only way that we as a suppliers can actually do better and continue with our operations is to be able to have actually a higher volume, which again, the concept of OCP and being able to actually build the product OCP compatible to be able to actually to market it to bigger markets, different audience is very appealing to us. So what is SDN NFV motivation and challenges? So when you see on the network OpEx, as we discussed, OpEx is an ongoing cost. Everybody is looking into, all the customers are looking into, network operators are looking to bring it down. But the areas that they really focus on network OpEx is resource utilization, policy, operation, complexity, and management. So the PMO, which is a present mode of operation, what is happening today, obviously on resource utilization is fixed. But when you want to go to FMO, future mode of operation, you want to be able to make that scalable. So you want to be able to scale that rather than being actually fixed with what you have today. On the policy is usually predefined, it's static. You want to make that obviously cognitive. On the operation is manual. That's why the OpEx cost is very high, because you have a lot of manual intervention when you are actually trying to actually work on your network. So you want to make that automated, obviously, moving forward. Complexity, it is very, the complexity is monolithic. It's fat. You want to make that lean and mean. That's just obviously the natural progression there. And the management is very much domain specific. You want to make that end-to-end, right? Especially that when you go into this open catalog that we discussed, you want to be able to mix and match different products, different modules, hardware, software, mechanical from different vendors, but you want to make sure that you can actually manage that end-to-end rather than specific domain area. So what we want to do actually, I mean, we are participating, obviously we are a member of the OCP, we've been a member for a while, and today we are introducing the next generation OLT, which we call it Open OLT. Now by open, I want to really make that clear what it is. When you're talking about OLT, a lot of audience may believe that that means that it can interoperate with any ONT. That's not really what we call an Open OLT. By Open OLT, we mean that it's a product, it's a platform which is SDN NFV ready, which is OCP compatible, and it's actually, we are building the base of the hardware, and we should be able to actually work with any of the customers with their own software, with tier 1 customers, tier 2, particularly service providers, that some of them are actually building their own operating systems. So we have actually built a very unique OLT that I'm gonna discuss that in a bit here. But traditionally the OLTs, which is like today, although it's moving really very quickly, it's a big system. You have multiple blades in the system, and it's traditional. It has worked very well. It's been in the network legacy for a long time. It's not very cost effective, obviously. It's not very energy effective. It's a lot of power dissipations, and it's not very size effective, right? Density. So the next generation OLTs, or the future mode of operations, are really moving very quickly into 1RU systems. So essentially top of the rack systems that you will see. Now, that is happening. It's not very, I wouldn't claim that there is a uniqueness as being 1RU. But what is unique about what we are actually proposing or actually developed is that we've developed a next generation OLT, which is a 24-port XGS PON. The uniqueness about this particular platform is that we have internally developed the PON MAC based on FPGA. Because traditionally OLTs today are designed based on off-the-shelf devices that are out there. They have basically PON MAC ASIC devices. But we've decided to actually be a little bit different here. So we've actually developed our PON MAC based on FPGA. And the value that we've gotten out of that is that the integration is much higher, meaning that we have actually 4 ports per FPGA. We have 6 ports on this system. With 6 FPGAs, each 4 ports, we've been able to actually accomplish quite a bit as far as size, as far as power density and as far as actually cost. So in fact, this is the first and the only device in the market today, based on our latest knowledge, is that based on FPGA PON and also an off-the-shelf network processor unit. So and again, it's actually, we have it in our booth that you can go and take a look at it here. It's the mechanical design is very elaborate. It's OCP compatible as far as the sizes, as far as the mechanics of it. Obviously, fan-based, redundant swappable fans, PSUs both AC and DC, and redundant hotspot power supply modules, and so it's a fairly elaborate and interesting product that we're working with, some of the features that we have here, as I mentioned before, it's a 24-port XFP XGS PON with 6 ports of 100G for uplink. It is a PON MAC, 10G PON MAC that we have internally developed based on FPGA. It's a non-blocking line rate architecture. It's deep packet buffers that we have actually implemented here. It's flexible to define wide ranges of match action, actually table processing. We do interoperate with variety of SDN controllers, actually Open Daylight and ONOS and all that. So these are all the value propositions here. We have a guaranteed fast failover and a very high performance processor. Again, it's an off-the-shelf network processor unit that we have actually working with one of our partners, and we have programmed that, and it's very unique. On the software side, it's obviously software agnostic. That's why we call it SDN NFV ready, if you will. So it is a layer of the hardware that we have developed, and we are working very closely with Volta. So it is Volta compatible, virtual OLT abstraction layer. So hardware abstraction layer. So we're working with Volta very closely. So this system, it will be fairly available, very soon actually available in the next several months for lab trials, but it would be very compact in a sense that you have your hardware, we have all that abstraction layer ready for you, so you can actually put your own software or operating systems on the top of it, and voila, you have your system. So that's really on the software side as well. And supports the third-party OS, obviously. So that's really actually the gist of this conversation here, that we want to really start working with service providers, with some of our customers. We are engaged with a number of customers right now. In the middle of this year, in June, July timeframe, we plan to actually do some lab trials, and towards the end of the year, this product will be available for GA, or general availability. So again, the differentiation is in FPGA-based for PON MAC and NPU for basically the switching system, which is, again, very unique in the market today. So I can give you some, a little bit on the company, Cambridge Industries Group, or CIG. We are a company based in Shanghai. We have a major operation here established about 1.5 years ago here in Silicon Valley in Santa Clara. We have over 600 engineers both in Shanghai and Silicon Valley, and our manufacturing personnel is over 1,500. And we have a sister manufacturing operation in Germany. The focus of course, the company's focus is R&D innovation, high product quality, customer support, which is top on the list on our basically focus. And in 2016, actually 17, I think we actually sold or shipped more than 30 million units. So in other words, our operation, our factory can do about 2 to 3 million units per month. The network technologies that we focus on is optical and copper, the ONTs, Open OLT that we just introduced, ROADM, that we are working on that as well. SFP transceivers, carrier Ethernet switches, DSL, G.fast, MoCA, G.hn, these are all the areas that we have expertise we're working on. And wireless, home networking, Wi-Fi, LTE, and femtocells. And the R factor is one of the areas that we are really focusing on. So we are going very quickly into automation. And you know, basically, if you visit our factory, you see all the robots just basically walking around doing a lot of manual work that used to be done by human interface. So that's really moving forward very quickly here. So it looks like my time is actually up here. So again, $500 million company, ODM, JDM. I guess, sorry, my time is up here. I don't think I have a lot. We have a big presence in Silicon Valley, 75,000 square feet operations that we have here. And let me just jump very quickly. These are some of our customers, the ODM, JDM customers that we are working with. And then we have some of the end customers, which are through our ODM and JDM engagements. These are the customers that are being actually served here. You know, Verizons of the world, TDSs of the world, and all that. So I guess I'm done here. Sorry about that. I have to cut it short. I talk too much. Thank you.